So I'm going to tell you a little bit about what we're going to do for today's session. This is the intro session, and as Craig alluded to, this is where we're going to try to get you excited about CNC. And then after this class is matured and delivered a few times, this is our pre-pilot version of this class. Vince has taken on the task of creating and will be presenting the first class on operations and safety. And that's going to be a hands-on class. In this class, I'm going to talk a lot. You're going to ask questions about things that you want to know more about. And then Dave is going to do a demo on the legacy machine so you can get a feel for what it's all about. But in this session, we're not going to have time for people to have hands-on. Sorry if you're disappointed, but you'll just be that much more excited about Craig's class. So what we're going to do is, you'll see in a moment, there's 3 questions that I'm going to attempt to answer with the class. We're going to talk about the hardware. We're going to talk about the software. We're going to provide a demonstration. And then, those of you that are a member of the CNC SIG, you saw that I sent out a request to be a little famous. Send me some photos. Send me some narration about your work. I got 10 folks to send me work. It's just spectacular. If you don't come away inspired by what you see tonight, CNC is not for you. So one of the things that we're going to try to do is, in these 3 questions, I'm going to reference a guy named Casey Powell. Anybody know Casey Powell? Doesn't ring a bell. Casey Powell was a sales exec when I met him at Intel in 1978. So this is a picture of Casey, kind of how he looks now. I met him in '78 when I was a product manager at Intel. And one of the scariest things for product managers to do is to go out into the field and train sales folks. They just rip you a new one if they didn't like what you were saying. And what Casey said to me and other product managers, when you came out to the field to train people on a new product, 3 questions you need to answer. What is it? Who wants it? And why? So my goal tonight is to answer those 3 questions. So here's the quick answers to those 3 questions. I believe that CNC routing, a CNC router, this machine is the most versatile machine in the wood shop. The other thing is, it's not just a piece of hardware, it's not just a machine, it is a system. There's a lot of software involved with making this thing happen. If you're comfortable with software, that's great. The design opportunities are fantastic, and we're going to explore what all of that means. You just have to be a user. You have to think that spending time in software on your computer is fun, not frustrating. You have to think that if you iterate a design 3 or 4 times, well, I'm learning in that process, I'm not frustrated in that process. So I think that being comfortable with computers, using them, is part of it. Second, is a complicated piece of equipment. It takes a while to gain some experience to learn your machine. Just like any piece of equipment that we use in the shop, whether it's power tools or hand tools, there's technique and experience that feeds all of that. You will develop some of that on these machines as well. A lot of woodworkers that I know are happy taking designs that other folks have created and replicating, adding their own spin to what the plans are and doing their own. And you can certainly do that on CNC. But to me, one of the best opportunities about CNC is the ability to do your own design. That can mean combining already existing elements into your own design, or it could mean drawing, sketching, creating 2D and 3D objects in design software. To me, it's a very compelling part of it. The other piece, especially for folks that are involved in professional replication of their work for sale, or involved in toy drives or other things where there's a lot of product that needs to be reproduced, and hopefully with a certain amount of reproducibility, CNC machines are really helpful for that. You can cut multiple things at the same time. You can load different pieces of material on and load them and cut them identically over time. We'll talk about the particulars of all of that in a little while. But for replicating work, it's a real productivity enhancer. This is a bit of an eye chart, but I found this diagram on the internet, and I really liked it. It's a little hard to see in the back of the room, I understand. What it's showing is what is process workflow in a wood shop. It starts with lumber. There's initial stock breakdown, chop saw, If there's sheet goods involved, there's a panel saw. You prep it, you make it S4S, you get it ready to go. Table saw, jointer, planer, you come around, you sand the thing, and then you get into shaping and joinery. And here, traditionally, is where a router table or a table saw begins to come in to help put the work together. Band saws, table saws, drill presses, workbenches, and here's the handheld router that's helping in the shaping and joinery process. You sand it, you might turn some stuff on a lathe, and then there's the artistic part, ornamentation, scroll saws, veneer stations, hand carving, and then finish, assembly, glue up, prep, and so forth. Cool, right? All of these places are places where CNC routing has an opportunity to add value to woodworking. This is a list of all the places where I have found, and we will be able to demonstrate where value for a CNC router comes in. Shaping and joining. There's all kinds of ways that you can use CNC machines to do this. And one of the more sophisticated ways, believe it or not, is to cut dovetails. Drilling is a piece of cake. You stick a drill-like bit in that thing and let her go to town. Those of you that have ever tried to make cribbage boards, 200 and some odd holes, you can tell me about jigs and templates and how fast and easy it is, but all you have to do is put your piece of material down, put in your program, and watch for a half an hour, and your holes will be drilled. Perfectly reproducible, perfectly spaced. Sure, you can use it as a regular router. Those of you that have done plunge routing know what the Z-axis is all about. We're going to talk about X, Y, and Z in a little while. And if you get a schmancy machine, like some of these guys have, with a rotary axis will hold a piece of material longitudinally and turn it while the carving bit comes down and operates on it. And you can create amazing things, lathe-like turning that you can do on a CNC machine. We have some examples of that work that we'll show later on. Ornamentation is where CNC routers are most commonly known. If you were to say, what's the most common application of CNC machines? It's probably sign making, plaques, trophies, things of this nature. Okay, some of the benefits of using the machine. This is a point that Dave had made when we were putting the presentation together. You can take your piece of material, put it on the bed, clamp it down or hold down the workpiece. So in one setup, for instance, the example that I'm using here is making an elliptical cribbage board. So you start with a rectangular piece of stock, clamp it down to the machine, put in your tool paths. You can cut your fancy engraving, you can drill all your holes, you can cut the elliptical piece out of that rectangular piece of material and do it without ever changing your setup. So you can make 100 all the same. So the repeatability is important, especially if you've got an assembly with multiple components that need to come together. The precision and accuracy of these machines, once you've got your machine set up and aligned, is better than the stability of the material you're working with. So we've got 10 times more accuracy in what we can do on the machine than the stability of the material you're working with. And that, in conjunction with the repeatability, means things are going to work the way you want when they need to come together. First of all, let's talk about the machine. We have a machine right here in front of us. First is the machine. Key components in the machine. You need a bed. This is the bed down here. Hiding underneath this piece of MDF, there's a solid bed that supports the workpiece. On top of that, we put a spoil board. Most machines use stepper motors. These contraptions up here in order to drive the axes. We've got one here for Z, we've got one here for Y, and there's another one hiding in the back for X. Some machines have 2 stepper motors to move the gantry back and forth, and those steppers need to stay in sync just because it's a heavier piece of stuff that they're moving around. The gantry is the thing that holds the cutting device. So this is the gantry all across here. This machine uses a router. It's a Bosch router. Higher-end machines will talk about spindles and liquid-cooled and for production work. But for low to mid-range machines, a router like this, a couple of horsepower router, is the typical bit that's running it. And then you need some electronics to control the gizmo. In this case, we've got a small PC that's running the machine control software sitting underneath it. None of the software that we're going to talk about requires particularly high-powered machines. Standard desktop PCs, this little mini PC is all the machine control stuff needs. So this is one of the CNC machines that's offered by Rockler. The brand name is Axiom. This one has a 24 by 48, as you can see, bed with 6 inches of Z. That's typically about what you get, 6, 8 inches, something like that. There's usually not a heck of a lot of Z. It's a higher end spindle. You can see it's liquid cooled. It doesn't require a little PC. They've got a little embedded dedicated computer that runs the machine. They use ball screws, which is typical for a mid-range machine. So the machine that we're still talking about here has T-track for its table. You can see the T-track down here. Very handy for clamping down material. Optional stand and storage, and it's an $8,500 machine, which is kind of a mid-range price for some of these guys. Craig mentioned that there's a new machine on the way. This is a picture of what that is. It's got a 3 by 5 foot bed, so it won't handle a whole sheet of plywood, but it'll certainly handle some sheet goods. It's a beast. These legacy machines are really solidly constructed, all steel. On the slightly other end of the spectrum, but one of the more popular, let's call them hobbyist machines, are the Shapeco. How do you decide what you need? Well, there's a lot of different factors. You're a pro. You're going to use this in professional work. You're going to want something pretty reliable, because when the deadline comes and the router motor burnt out because you used it too much, that's going to be a problem. So maybe a spindle will give you more of the reliability that you're looking for. The bed size, as we talked about, is really important. If you use sheet goods, you're going to want a big bed. No question about it. But if you're doing boxes and signs and ornamentation, I haven't yet reached the limits on my 2x2 bed that I've got on my machine. I'm perfectly happy with that for the time being. What do you want for a work surface? Everybody's got to have some kind of a spoil board. I have found that T-track is a very common option on the machines. You get to use clamps and stuff like that. Although a lot of the work holding that I've done, I've been using double-sided sticky tape. Works just fine. Tracy Ann uses blue painter's tape and CA and accelerant. Works for her. So we'll talk a little bit more about work holding, but thinking about what kind of material you're going to have and how are you going to hold that sucker down is something to consider. Rotary axis we also mentioned. If you're interested in turning but you don't have any lathe, great for making legs, canes, as we'll see, any type of material that you would typically imagine cutting on lathes. While we're talking about rotary axis, so there's the 4 axes, as the rotary axis is often called the 4th axis. Craig and Smith and Jones had the opportunity to go down and see the Pilot Pro, and I looked at their YouTube video, and it has a 5th axis. And the 5th axis is the Z axis. The cutting machine can rotate this way. So one of the things that you can't do easily with CNC is undercuts. Questions about how to decide what you want. I'll give you one more chart to put some of this stuff into perspective. From the low end to the high end, this basically summarizes the stuff that we've talked about. Some guys or gals build their own. There's router parts companies. In fact, Avid CNC, the people that made the kit that I assembled, started off, the company's name was Router Parts, and they sold parts, and then they finally said, hey, if you put enough of these things together, you can have a kit, and then we can engineer it so that it'll actually work. Okay, let's talk software. This is the fun part. So, first I would say, there's 3 main components of software that you will use on your CNC work. The first is doing your design. You can draw it, you can create it in a variety of ways. We'll talk about some of the different kinds of software, examples of that software that we're going to use, but this is where you're sitting down at your desk, you got something in mind about what it is that you want to make, and now you have the opportunity to render that in your software. And what you end up with is typically 2-dimensional, 2D drawings of the work that you're going to produce. Well, that's great, but now you got to make it. So now we need something that's going to convert that design, those plans, into instructions that can move that bit around and have it make what it is that you want it to make. And that software is called the CAM software, computer-aided manufacturing. And that software's job is to do just what I described. It basically takes your drawing, could be two-dimensional, could be three-dimensional, and turns it into cutting instructions for your machine. Critical piece. The output of that is a script, a program. And the program basically says, take the head and move it down here and move it over here and turn the thing on and cut it over here and go back and forth a few times like that and then drill a hole and you're done. That's kind of the program, the script, if you will. We take that script that comes out of the CAM software and load it into the machine control software. That's the stuff that's running on that little PC that's under the machine right now. And that's the software that will then tell the steppers and the thing and the router and the spindle what to do to make your part. Bing, bang, boom. It's just that simple. If there's one slide in this presentation for you to wrap your heads around, this is it. And this is the part of the presentation that I struggled with. How do I give an overview of what this process is like? This slide is the best I've found. So let's go through it a little bit. It's 3 stages. We kind of highlighted them with the 3 different categories of software. In one case, you're going to do your design. Stage 2, you're going to create your tool paths. The 3rd stage, you're actually going to cut your work. You can see what the activities are, creating the cut strategy and the control of the machine, and then the different categories of software that you use. This is the basic process for how you do stuff on a CNC machine. The notion is there's 2D, 2.5D, and 3D design. What the heck is 2.5D? Is this like an Einsteinian thing? No. 2D is when you create a design and all the cut levels, the depth of the cut is all the same. In some cases, like if you were doing engraving, you might actually go all the way through the material and cut it out. That's 2D design. What is this 2.5D thing? The 2.5D thing exists because 3D is hard to design. You got to think in 3D. You got to draw in 3D. You have to use 3D design tools like SketchUp or Fusion 360 or AutoCAD or complicated stuff. If you have that interest, if you have that background, if you have that ability, you can create fantastic things. Not everybody does. 2.5D gives you some of the capabilities that you get for 3D, but you get to design it as if it's 2D. So it simplifies the design. We're not cutting 2.5 dimensions. Everything is 3 dimensions, right? The material has thickness. So that's not the issue. The issue is how hard is it to do the design work? And doing design work in 2.5D is a lot easier than doing it in 3D. Although, for some things, like this particular example of 3D, if you can see this slide, there's contouring. So this engraving, this cutting of the letters is wrapped onto an undulating 3-dimensional surface. So first you have to use your 3D software to create that undulating surface, maybe not all that hard, and then put some letters on it and tell the software, wrap those letters on top of that undulating surface and go cut it. Not so hard to do. The 2D stuff is a piece of cake though. You just say, I want the letters, 2.5D contour. Use this bit, cut this font, bing, bang, boom, and the software does the rest. So it really does simplify the design. My advice is start with something like this in the world of design, get some experience with that, understand your machine and how it cuts, and if you want to do 3D, it's awesome because it really opens up the world of possibilities. You can make anything then. Some examples of 2D, 2.5D software. Carbide Create is an example. It's the stuff that comes bundled with Shapeco. It comes for free. It supports some other CNC machines as well, but they really focus their connection between the software and the hardware on Shapeco hardware. But if you wanted to download a version of it and check it out, you certainly can. Vectric V-Carve. Who uses V-Carve here in the shop? V-Carve Pro. V-Carve, okay. Yeah, and Aspire. The first thing I learned when I started to get into this, what software is people using. First of all, Vectric is the brand. It's an English company. It's very mature. Their software is in version 11. It's feature rich. It's very stable. It's not impenetrable in terms of learning how to use it. It's really cool. And V-Carve and V-Carve Pro are very popular. So if you're just getting into all this, take a look at V-Carve. There's a free version of SketchUp that still works. There's a free version, and if you want the pro high-end thing, it's about $500 a year. 300. Pardon me, 300 a year. So the comment is we've been talking about hundreds of dollars and $2,000 for some high-end software. That's not necessarily the case. You can do very capable work for free. Some of the stuff is free. Inkscape, as an example, is a dandy 2D design package. It's open source. So if you're an open source fan, you'll be able to find versions of that stuff for almost everything. Blender, incredibly powerful 3D package. It's free, open source. So we're talking about commercial software, support, community, and all of that, but there's other options as well. Thanks for highlighting that. How do you do this design stuff? Those of you that are really good at doing design can just sit down and draw. Not everybody is able to do that or do something in a design that they'd be pleased with when they got their results at the end. But it's not that hard. Those of you that have used any kind of drawing package, you know how to draw a rectangle. You collect around the rectangle thing, you stretch it out, and you got a rectangle. It's not so hard. Or an ellipse or a circle or any of those objects. You can create all those things, standard drawing, 2D drawing stuff, and do it in your package. You can import stuff. Michael was asking earlier about, can I import stuff? I can import stuff from other 2D or 3D design packages that I might be familiar with and bring them into something like V-Carve and play with them some more. So as a source of inspiration or elements for your design, being able to find stuff on the internet is really cool. Third thing is pictures, photos, scans, bitmap images in text speak. And there are tools in a number of these packages. I'll again mention V-Carve because I use it and I'm familiar with it. That is able to take a bitmap image and turn it into the vectors that are needed in order to carve them. You can do what's called a raster scan of those images, or you can do some additional processing on them. So all of those three ways, and of course they can all be combined in any project that you work on. Okay, let's talk a little bit about this CAM business. This CAM stuff is, again, the software that's going to convert your design into tool paths. That's partway along the path to giving the instructions to the machine to cut. Those tool passes you can read here are packaged into what's called a G-code script. We're going to talk about G-code and what that means in just a minute. There are some standalone CAM software packages. MeshCAM is one of them. It actually runs on Mac. Most of the stuff, by the way, works on Windows. The design stuff works on Mac and Windows, of course, but a lot of the CAM stuff and Vectric software is Windows only. When it comes to CAM software, most folks don't need to buy their own CAM software because a lot of the CAD stuff that we talked about includes the CAM features. So in V-Carve, as an example, you do your design work and then you push the button and it says, okay, I'm going to switch you over to the CAM side. And all the tools for the CAD stuff is over here and all the CAM stuff is over here, and it works the two together. All right, so what's this toolpath business? This is one of the CNC things you need to kind of wrap your head around. You've got this design. And let's say you have a rectangle. You want to carve the rectangle. How do you want to carve that rectangle? Do you want to remove the insides of that rectangle? or do you just want to carve the line around the rectangle? Well, hopefully, as you think of your design, you know which one you want to do, but somebody needs to tell the software which one. So what I just described is the difference between a profile, going around the outside, or creating a pocket, carving out the middle of that rectangle. Okay, speeds and feeds. We talked a little bit about speeds and feeds earlier, so now you've got a design, you're telling the tool path to move around. How fast is that bit moving around, and how fast is it spinning in your spindle or router? There are, as was highlighted, a few different ways to do it. The goal is you want it to cut clean, you want chips, not dust, you want to maintain good tool life, you don't want to burn anything, you don't want to break your bits, you want all that stuff. And how do you do that? As was mentioned, the tool database, it's a database of tools that's in both the design software and in your CAM software. If you're going to be doing that pocket cutting, chances are you're going to use an end mill. So there are conventions of which bits you're going to use. If you're going to be doing really detailed work, you're going to want tiny little pointed bits like that in order to do the detail work. So on the left-hand side is the 2D drawing that Dave did of the sign that we're going to cut tonight. And then the 3D version, what you see here is a screenshot, but like in other 3D software, you can use your mouse and change the profile, the view that you have of it, so that you can see the edges and whether those letters are proud or relieved. Exactly, spin it all around. And, as we'll also mention, the sequence that the tool paths are cut in can sometimes be important. Tabs is an element that you can add to the design where you're going to leave a piece of material periodically around here because it knows that it's a cutout piece, and it'll leave those tabs for you to hand cut and do the final separation. Okay, last piece of software. It's almost demo time. Machine control software, the last piece. So the last thing that we did after we did our preview in our CAM software was we saved the tool paths as files on our computer. And those tool paths is the script with the G codes that the machine control software will then load and cause the machine, once you've pushed the right buttons, to execute. So the functions of the machine control software, as you can see, is load and run that software. There's a whole thing that goes on about setting the origins, the hardware origins of the machine, reference origins, your workpiece. The tool needs to know where your workpiece is. And that's part of the setup that Dave will take us through so you can see what that looks like. One of the mistakes you might make is, oh, I told the design software the origin was in the middle of my piece of material, but I didn't set the machine up that way. I told it that it's actually the corner of the material. Oops, that's a problem. G-code. We won't get into a lot of detail about G-code, fortunately, because we don't have to. The machine understands it. There's lists of hundreds of G-codes. One last thing, and then we're going to turn it over to Dave. He's going to talk about how he holds down his work. There's lots of different techniques. We alluded to some of them earlier. One of the preview things, one of the things that you see on preview is where the tool will start, and then it zips across to where it's going to start cutting. So if you remember that preview, you won't put your clamp in that path. So keep your clamps out of your tool path. The workpiece must be held securely or else. And it also must be flat to the gantry, especially if you're doing particular carving. Sometimes we all know wood tends to warp. You got to either clamp it down really good or give it a surface planing to make sure that you get good consistency, or what the technique that Dave called touch-off. Touch-off is the procedure by which the machine knows where the material is, the top of the material, for the tip of the bit, right? And that 0 point, that touch-off point, is really important. If you've got a warped piece of wood, that surface is going to change. So you've either got to flatten it out or readjust your touch-off point so that your carving is to the proper depth. The other thing that happens, you also need to align your piece of work properly so that if you have a line that goes all the way across the x-axis and you expect it to be parallel with one of the edges of your piece of work, you got to make sure that you mount your piece of work so that that works. Time for Dave's demo.
So we aren't going to carve a sign, but we're going to carve elements of the sign. So fairly quickly, what I'm going to basically show you is the CAD side, which is represented with this set of tools over here, and the CAM side, which converts your drawing pieces into what we call tool paths. And a tool path might be as simple as something as carve from point A to point B, or do a circle as Vince suggested, or carve out a letter or whatever it is. So you're creating a tool path with these tools over here, which then get converted into the G-code that gets sent over to the CNC. Set of tools. You've got certain file operations. You can go in and set up your X, Y, and Z. It says, okay, the width of this particular material, the height of the material, and the thickness of the material. You know, it's important, depending upon the kind of work you're going to do on your piece, that you know those elements. So we'll change, for example, the parameters. So you notice all of a sudden my drawing no longer fits. We'll have to scale it accordingly. See the little tabs up here? You can grab them and make it a little smaller. There's a tool in here that says, okay, I want to center all this on the middle of my workpiece. Now, Richard also mentioned earlier that you need to tell the system where the origin of your work is going to be. Two places are very common. One is in the center of the piece. The other is at a position typically at the lower left-hand corner where X and Y cross at 0. And for this particular one, this is going to be our origin. So that translates to the board and this corner right here. Okay, the other thing you can do is you can say, I want to look at it, and you can say, okay, we've got the X and the Y defined, but we also want to know whether we're going to reference the top of the workpiece or the bottom of the workpiece. And that's done here. Z0 position, material surface, or machine bed. And there are other things you can do. For example, you may want to have your X0, Y0 in here so you can do an offset, things like that. Then the next thing you want to do is start actually doing your design. And there are very simple elements that we have on this. We have a couple of ellipses and we have some text, very simple. To do an ellipse, that tool right there draws from the center. You can shape it, play with it, do whatever you want. And if you can also go in and enter the parameters here. For example, I could say I want that to be at 0, 0 and apply it. And the ellipse is centered at our 0, 0 position. Good. So we've drawn a couple of ellipses. We've put some text in it, and as was raised over here, what is this gray area in the middle? Well, what we did is we created a little bit of a model. If you remember Richard's images of this thing in another iteration, there was one where there was sort of a dish carved out, and the letters were stood out proud in that dish. So what I'm going to do is very quickly put together yet another ellipse, and I'm just going to put it up here. And what I want to do is create that dish that we talked about. I'm going to go into modeling, and I'm going to very quickly choose create a shape. And so there are various shapes you can do. You can do peaks, you can do coves, you can do roundovers, you can do sort of an arc. And I'm going to do a very simple dish shape. I'll just do it around there. And there is that gray area we talked about before. I can apply it and close it. And then later, when I go into my cam side, it will take that shape and carve it out. The best thing to do is take the V-Carve Pro and just play with it. So let's say I have defined what I want, very simple. This line will be the cutout. This line will be the dish. There's the text we're going to put in it, and that's all we're going to do. So what we can do is we can say, all right, we're in the CAD side, let's go over to the CAM side and create those tool paths. And I've done those for you, but I'll do them again. So for example, so you notice this big oval out here? So I can recalculate each of these. So I can double click on it, calculate it. Now it's sized to the material. Or there's a tool up here that I can just go recalculate them all. So one thing we can do is we can say, all right, here's the profile. I'm going to go in and I'm going to so what I chose to use to create that shape is an OG bit. So it creates the OG shape. You can do it with roundover bits, ball nose bits. It just takes a lot of steps to do it. So there's great form shape bits that you can use to do that. We'll leave it as is. And now we're talking about a cutout profile. So I've made my shape and I want to cut out in this hollow here so that all I have left is the board and the border. I'm cutting all the rest of this away. So if I preview that, okay, so you notice the blue background coming through, so I've cut through the material. Now, earlier I mentioned that you can tend to start from the top of the board or the bottom of the board. If you're doing a lot of through cutting, you typically want to start at the bottom of the board so your bit doesn't go below that and cut into your spoil board. I've cut into the spoil board hundreds of times, and then another thing you can do is you can say, all right, now I've got my shape. I'm going to eliminate the excess material, and I'm going to start looking at it. And that's kind of what I'm trying to accomplish. So the other thing I'm going to do now is I'm going to cut that dish. And what I want to do now is show a different effect of that text, which is a V-carve, which uses a V-bit, one of those red ones that Richard showed you up there. And in this case, we're using a 60-degree V-bit. And if we calculate that, reset the preview and preview it. Oops, sorry. Okay, that's not what I intended to do, but it's an interesting one. This thing cut the entire dish with that 60-degree bit. Come on, there we go. Now calculate it. And we'll get to just the Richard, and it V-carves the Richard. And you notice the depth here is relatively deep. And I'm going to do both of those tool paths. I'm going to reset and preview the visible ones. Then I'm going to get my dish and the Richard raised and that sort of thing.